Hello, my name is Preston, and today I'll be conducting a chemistry experiment on the topic of the rate of solubility of solids within water versus the temperature of the water, and how temperature affects rate of solubility of solids. So something I learned during my time in Chem 120 is what I have written right here, is that solubility of solids dissolved in water tends to increase with temperature increase. So solubility of solids in water and temperature have a direct relationship. Okay, in this experiment, my solid I have is pure cane brown sugar from your local HEB. I'm gonna have 3 glasses of water with all the same volume, which is about this much. I just kind of eyeballed it. This one is room temperature, and then I have some boiling water right here. And then when it's time, I'm gonna put the boiling water into this glass, the same amount. Then I also have some water chilling in the freezer, so it's super cold, and it's the same volume as that one as well. Same type of water, same glass, so we got all the constants. And so my independent variable would be temperature of the water, because we have room temperature, which is like a medium, a colder one, which is low temperature, and then a boiling one, which is high. And then my dependent variable would be the rate of solubility of the brown sugar in the water, and some constants would be the glass, the volume of the water, the amount of brown sugar. I'm gonna put the same amount every single glass, and then yeah, we're just gonna time it and see which one dissolves the fastest. Okay, so I've been letting the water boil now for about half an hour, which is 30 minutes, and then have the water in the freezer in there for about 30 minutes, because I don't actually want it to freeze, right? Because we gotta keep it water, not ice. And then I'm gonna have 1 tablespoon is gonna be the amount of brown sugar I pour into each glass of water, and then I'll stir it up a little bit and then see what happens. So I'm gonna grab the boiling water here. And pro tip: always turn off your stove. You don't want no fires. And then you gotta be careful here and not burn everything. And a little more. That's pretty even. And we grab the water out the freezer. Very cold, but not ice, so that's what we want. And now we're gonna put the sugar in there. So I've put about a little less than a tablespoon worth of brown sugar in the spoon. And now I'm gonna pour it into the room temperature and stir it until it's completely dissolved. Let's go. And there's still particles in there, so we don't keep stirring. Alright, I think we're gonna call that completely dissolved. Now we're gonna do the same thing with the boiling hot water. And so, same amount of sugar, same amount of water. Here we go. Oh wow, it's already done. And so as we can see, the hot water dissolved much quicker than the room temperature, even though I was stirring them about the same amount. And for the third glass, same amount of sugar, same amount of water, it's just colder temperature. And so we're starting in now. And we will stir it and see how long it takes. And for those watching at home, I'm sorry for the noise. It's very loud. Almost there. So there we have it. All three trials are complete. And just as I hypothesized, the boiling water, which is still steaming as you can see, it dissolved all the sugar the fastest in just over 10 seconds. And it broke down the particles because it broke down the sugar molecules because the water was at the highest temperature compared to the other two. And the room temperature was pretty average in terms of time. It took just over 30 seconds or half a minute to dissolve all the sugar molecules. And then the really cold chilled water in the freezer took just under a minute, so 54 seconds to dissolve all the sugar molecules. Okay, so as you can see, as a result of this experiment I just did, the property I learned in Chem 120 is that solubility of solids dissolving in water has a direct and positive relationship with temperature of the water, so they have a direct relationship, and so the experiment proved that, and so it held up, and so we're all good. Thank you for watching.